Linear regression. The purpose of this video is to take the data that we've collected. In this case, the data shows full-time employees, the age of those employees versus the income they make. We take that and create a scatter plot from it. And the scatter plot then, we're going to use it to create a line of best fit. And we're using something called the least squares method. And I'm just going to draw an approximate line of best fit. Try that again. And what I tried to do just by eye was to have an equal number of coordinates above and below the line. I wasn't quite successful, but what we're going to do with the formula is we are going to find the perfect line of best fit. And what the formula does is measures the distance between the coordinates and the line of best fit. And these distances are called residuals. And when you add up these residuals, you will get a value of 0. So if this happens to be +1, and this is -1, let's call this +2. And we'll call this -1 and -1. So if we add those numbers up, we will get a value of 0. And so what we're trying to create then, just bullet points here, is the residuals add to 0, and the squares of the residuals. Squares of the residuals are the least squares. And that should become clear as we go through the formula. So the line goes through the coordinates, approximately an even number above and below its line, but when you add up those distances, it creates a value of 0. And by doing so, when you square those values, it is the least amount when you add them all up. So just to reiterate, we're taking data into a scatter plot to find the line of best fit. And we're going to find it in our usual formula of y equals ax plus b. You might know a as m, just depending on how you learned what a linear relation was. Okay, so there's our data, and in this table I've squared the x's and I've come up with the value of x times y. And we're just going to add these up now. So this will be 292. This will be 329. And then we have 11, 7, 12, and 13, 2, 21. Once we create our line of best fit, we'll answer a couple of questions. We'll predict the income of a new employee who's 21 and somebody who's retired at this company. So the least squares method finds the line of best fit. We have an ability to find the value of A, which is on this side, and the ability to find the value of B, which is on the right-hand side. So we take our values. So the sum of the x's is 292. The sum of the y's, 329. The x squareds is 11, 7, 12. And the xy's is 13, 2, 21. And all we do at this point is sub in to our equation. So the value of A equals n, which is the number of coordinates, in this case 8, and then put in the sum of the xy's, which is 13, 221, minus the sum of the x's times the sum of the y's over top of, again, the number of data points, the sum of the x squareds, and the sum of the x all squared. So that's 13 to 21. Okay, at this point now, a will equal, approximation, 1.15. So we're halfway there. Y equals 1.15x. All we have left to do now is solve for b. So b is the average of the y's. So the y's were 329, 8 data points, 41 and an eighth. The x's, the sum of those, was 292. Finding the average, again, divide by 8, and that's 36.5. So plug those values into our formula. 41 and an eighth. Subtract the a we've already found times the average of the x's, and b will equal negative 0.85. Chose the wrong color there. I'll just go over top. And there it is. There is the equation of the line of best fit using the least squares method. So there we have our formula. And we want to predict the income of a new employee who is 21 and somebody who's retiring at the age of 65. Sub in for x. Sub in for x as well, only this time the number is 65. Y will equal 23.3, and for the 65-year-old, 73.9. So these are in thousands of dollars. So $23,000 for the 21-year-old and almost $74,000 for the 65-year-old. Thanks for listening.